differentiation of e to the function x. So now we know that the simple little rule that if y equals e to the x, then the derivative is e to the x. We're going to extend this to a very important rule. Okay, now in the first case we're going to say let y equal e to the function x, and we're going to replace that function x with u in that very first line. So y equals e to u. So when we differentiate this with respect to u, we'll get dy du equals e to the u. And of course, if we differentiate u, we're going to get a derivative function f dash x, whatever that function may be. So using the chain rule that dy dx equals dy du times du dx, which we proved earlier, then all we have to do is replace that dy du with e to the u, which we've worked up here, and of course our du dx is f dash x. Now u is, of course, fx, so we can replace that with fx here, that u goes into here, fx, and we have the very important rule that the derivative is f dash x times e to the function x. Now just to give an example of one of those, so we had y equals e to the x squared. Therefore, dy dx will be equal to, we differentiate that, which is 2x, and of course that just stays as is. You don't change that. Just compare that to the other rule when you've got y equals something like x to the fourth or something. Then dy dx there, or y dash if you like, is equal to 4x cubed. So totally different rule. Alright? So the 4 comes down and you take 1 away. So the x squared doesn't come down. You differentiate first when it comes down, and you'll leave that alone. So now you've got two rules, don't get them confused. And you can also extend this. You could have, say, y equals e to the sine x. No problem with that. Y dash is equal, the derivative of sine x is cos x, so that's just cos x e to the sine x. It's quite a simple one really, because all you need to do is differentiate that and put it down the front.